Hello, in this video we are going to see the continuity idea or topic. We are working with functions, and it's a very important idea in mathematics. Continuity, we will see in no time, has this definition, and it's not as easy as it appears, because sometimes we need to prove much more things than we think we need to do. Okay, which are the objectives of this video? Okay, we are going to define and try to understand the idea of continuity at a given point. We will explore different types of discontinuities and conditions for continuity, and we will apply these concepts on some examples that you will see. I hope they can clarify the idea of continuity. Okay, requirements. Calculus, a little bit. Limits, you need to know the idea of limit. We need to be familiar with some types of functions like polynomials, exponential functions, but it depends on the exercise. Okay, I think in this video we are not going to see anything complicated. And okay, the ability to calculate some limits. Let's see how we deal with these ideas. Important thing. VIT, very important thing. When we say that a function is continuous at a given point A, okay, is continuous if this condition holds. Be careful. And this is very important. You can see the condition seems easy. There's a limit, there's a function, but in fact, it involves three conditions. Okay, as you can see, the limit should exist. I need to calculate this limit, and this limit should be a number. Okay, this is condition 2 on this list. Okay, the limit should exist. Second, the function at this point should exist also. We cannot say that function is continuous if the function is not defined at this point. Okay, so the function should exist at the point we are studying the continuity. And third condition, these two values, the limit and the value of the function, should be the same, okay? Because it could happen that the limit exists, the function exists, but the value is not the same, so the function is not continuous. So continuity, it's only acquired if these three conditions are true, okay? So be careful with that. When we prove continuity, we need to prove these three things, okay? So, sorry, by the way, in the previous slide, something that I just missed. This is the definition of continuity at a given point. If the function is continuous at any point, we only say that the function is continuous. Okay, next slide, let's see. When a function is not continuous at a given point A, we say that the function is discontinuous. But there are different types of discontinuity. Could be a finite jump, an infinite jump, or removable discontinuity. We are going to focus today on this last type of discontinuity, removable discontinuity. Is discontinuities in which the limit exists, the function exists, no, we can just add one point, but the limits from both sides exist, and the function at this point, at this given point, have a different value. So just making the point, taking the proper value, the value that it's obtained with the limits, then we make this function continuous. That is the reason we say removable, or we can change the function a little bit in order to make it continuous. Okay? So, okay, let's stop here 1 second. Important information. Okay, all these functions are continuous. Polynomials are continuous functions. Trigonometric functions are continuous functions. Okay, tangent, be careful with the tangent because it has some points at which the function is not defined. Exponential functions are normally continuous functions. Are continuous functions. Logarithms, be careful, in the domain of the function is also continuous. Radicals, absolute value is also continuous. Be careful because most of you remembered something about absolute value. Absolute value was something, is continuous, not continuous? It's continuous. The problem is at the point 0, normally, if we are talking about the absolute value of x, at the point 0 is not differentiable, but is continuous. The product of continuous function is a continuous function. The quotient of a continuous function is also continuous if the denominator is different from 0. The addition of continuous function is also continuous function. Composition of continuous function is continuous function. Okay, so we can use this information anytime we need, okay, in order to know if a function is continuous or not. Example. Look at this beautiful example. This is called a piecewise-defined function. It's piecewise because it's defined, it has different expressions on different intervals. When the function, when x is less than 0, when it's moving between 0 and minus infinity, the function is cosine of x. When x is positive, when we are moving in the positive part from 0 till infinity, the function takes the value 1 minus x squared. And exactly at the point 0, the function is equal to 0. Okay? So the question is this function continuous? Okay, look at this. Cosine is always continuous. It's continuous for any value of x less than 0. I don't mind. In this interval, from 0 till minus infinity, the function cosine is continuous, no problem. 1 minus x squared is a polynomial. This function is continuous in the interval 0 plus infinity. There is no problem in this interval. The key point is, okay, is continuous from 0 till infinity, is continuous from 0 till minus infinity. What happens at 0? Is continuous at 0? Then we need to study the continuity of this function at this point exactly, x equal to 0. Okay, how do we do that? We are going to calculate the limit from the right, the limit from the left, and see what happens. If we calculate the limit when x approaches 0 from the right, which function was defined in the right or to the right of 0? Let me go back 1 second. To the right, it was this function 1 minus x squared. It was the one defined from 0 till infinity. So, guys, I replace the polynomial in here, and then I substitute x by 0. So we got 1. The same happens from the left. If we approach from the left, which is the function that is governing this part is cosine of x. So I just replace the function by cosine of x. Cosine of x is continuous. When we, let's substitute x by 0 in this function, is cosine of 0. Cosine of 0, all of you know that is 1. So 1 coming from the left and from the right. Perfect. Both limits, the two limits exist and the limit is 1 then. But what happens? So the limit exists. The question is, the value of the function at 0 equals 1. Let me say that is not. This is not true. The function at 0 by definition was 0, so it's different from 1. So the function is not continuous. Why do we say that it's a removable discontinuity? Piece of cake. Because if I change this value at the beginning was 0. If I change by 1, then the function at 0 equals the limit of the function when we approach from the left and from the right. Perfect. So the function would be continuous just by changing this number here. Okay, so that is the reason it's called removable. Okay, what have we seen today? Not much. We just reviewed the idea of limit in order to calculate the continuity at a given point. We have seen that there exist several types of discontinuity, but we had focus on removable discontinuities, and we have put some examples how to solve them. I hope this helps you guys, and thank you for your attention.